All right, welcome back to activity 3. We're going to look at circles and how to get equations for circles. This is one that a lot of students find is pretty tricky, but we're going to work through it. So a circle is, well, you know what a circle is, right? But we're going to get a more formal definition of a circle here. We're going to think of a circle as the set of all points in the xy plane that lie at a given distance called the radius from a fixed point called the center. Which makes sense if you think about like this red circle here. You can think of that as like all of these points are the same distance away from the circle. And that's kind of what makes it so round, is that all the points are the same distance away. So that's a good way to think of a circle. And thinking of it that way, if we're talking about the distance, we're going to do this using the distance formula, which will, I think, help make this formula for a circle that we're going to get here make more sense. So starting with B here, the center of the circle shown right here is at the origin, 0, 0. So the distance from the origin to any point xy on the circle is r. So let's say this is a point over here. This is like your point P, which has coordinates x, y here. The distance from here to here, you can get using the distance formula, because those are your points, 0, 0, and xy. So when you do like x2 minus x1, that's just x minus 0, and y2 minus y1 is y minus 0. And that distance should be equal to the radius, r. And the same thing would be true if you did any other point. Like if this was the point xy that you're talking about, then you can still do the distance from here to here. That distance should still be r, and that should be true for any other point on the circle. Okay, so this equation must be true for any point. So if you just square both sides of this here to get rid of the square root, squaring the square root cancels out, and you get x minus 0 quantity squared and y minus 0 quantity squared. That should become r squared. And this you might recognize as just the Pythagorean theorem. When you have x squared plus y squared, let's see, x and y are the horizontal and vertical sides of this triangle here. So, and the r squared is the hypotenuse. So this is basically the Pythagorean theorem. It's the same thing as the equation for a circle centered at the origin. It's just x squared equals r squared. If you had a radius 2 circle, this would be x squared plus y squared equals 2 squared. If it was a radius 5 circle, this would be x squared plus y squared equals 5 squared, and so on. Okay, so now part C is a little bit weirder. Let's say that the center is HK. So that means this point right here is HK. And you want to talk about any point on the circle, like maybe xy is over here. Then the radius is still whatever it is, r. Let's write a formula that would work for any of these xy points. If I just want to say the distance from xy to hk is r, I'm going to write that using the distance formula. That's going to be the square root of, let's see, it would be x2 minus x1. In our case, the x2 would be like the x minus x1 would be the h. So that's x2 minus x1 squared plus y2 minus y1 squared would be the y minus k. That distance should be equal to the radius. So this is an equation saying the distance from xy to hk is equal to the radius of the circle. And in practice, we're going to have a particular number for h and for k and for r. Like we might be talking about the circle whose center is at the point 3, 5. That would be like your h and k, and whose radius is 7, and then the r would be 7. But this looks a little awkward like this. Sort of the standard way to deal with this is to then take this and square both sides. Is what this says, square both sides, to cancel out with the square root there. And that's just going to leave you with x minus h squared plus y minus k squared equals r squared. And this is true for any xy point on the circle. Okay, so let's do this for part B. I'll give you a little bit of instructions here, but I would like you to try it on your own. This equation for the circle, it's still going to have x and y as variables, but the center, instead of it being any old hk, is specifically 4 and negative 3. And the radius, instead of being any old r, is 2 times the square root of 6. So try to plug in that for h and k and r, and that will be the equation of a circle. I'll give you a moment to pause it, but then I'll do it myself. Okay, so it's going to be x minus 4 squared plus y minus negative 3 squared should equal r squared is 2 times the square root of 6 squared. And 2 times the square root of 6 squared, let's work this out over here. It means 2 times the square root of 6 times 2 times the square root of 6. And you can just regroup and reorder this to write it as 2 times 2 times the square root of 6 times the square root of 6, which gives you, the 2 times 2 is 4. The square root of 6 times the square root of 6 is just 6. So you get 4 times the square root of 6, which is 24. Okay, so this is just going to be x minus 4 squared plus y minus negative 3 squared becomes plus 3 squared. And the 2 root 6 squared gives you 24. And that is the equation for that circle. All right, so 3a, we want to state the center and radius of this circle. So in other words, we need to write it in this format. But right now, this has a plus and a plus here. It doesn't say minus. And also, instead of having something squared, it just says 16. So to write this in the right format, I want it to still be the same equation, but I want it to be x minus something squared and y minus something squared equals something else squared over here. Okay, so whatever goes here, we need to subtract it. We need to do x minus that thing, and it needs to be the same thing as x plus 3. So I think that should be x minus negative 3. X minus negative 3 is the same as x plus 3. And let's see, if this is y plus 2, that could be y minus negative 2. That's the same thing as y plus 2. And what do you square to get 16? That'll be 4 squared. So the center is the h and k that are subtracted here. So because this is the same as x minus negative 3, the h is negative 3. And because this is y minus negative 2, the k is negative 2. So the center is negative 3, comma, negative 2. And the radius is 4. All right, so let's graph the circle on the grid. So let's see, -3 is here, -3, -2 is right here. That's the center, and we're going to go 4 units in any direction. So if you go 4 units up from a y coordinate of -2, that's going to take you up to a y coordinate of 2 there. Or you could go straight down from -2 down to -6, 4 units. If you go straight to the left or right, that would be, I'll leave the xy coordinates in red so I can graph the points on the circle, the xy points in red. So if you start from -3 and go 4 to the right, that will put you at 1. If you go -3, 4 to the left, that will put you at -7. So the circle is all, and you could also go diagonally. So if you go diagonally this way, you'll get, I don't know about that far. So I'm just going to draw a circle that goes through all these points. Drawing a nice circle is harder than it looks, unless you're good at drawing. Okay. So, now what I want to do is I want to expand the left side of this to write this in general quadratic form. So what that means is take the x plus 3 quantity squared and FOIL it out, basically. So remember the formula from chapter 3 and also Appendix D. This is an important one. That if you have x plus r and you square it, you could FOIL it out. If you're not sure what this turns into, pause it right now and FOIL it out. Do x plus r times the quantity x plus r. You'll get x squared plus 2rx plus r squared. And in this case, instead of r, we just have 3. So this is going to turn into x squared plus 2 times 3 times x plus 3 squared. That's that part of it is right here. Next we have the y plus 2 squared. So for that one, the r is now going to be 2. So this is going to become y squared plus 2 times y plus 2 squared. And that should be equal to 16. I'm just going to simplify this a bit. We're going to get x squared plus 6x plus 9 plus y squared plus 4y plus 4 equals 16. I'm going to subtract the 16 from both sides because it says we want to get 0 on the other side. And then combine some like terms. We have 9 plus 4 minus 16. That will all work out to -3. And then there's still everything else. The x squared plus 6x plus y squared plus 4y there. Okay, so that is now in what we call general quadratic form. Now, this kind of thing is not as useful as thinking of it in terms of like the quadratic formula, not the quadratic formula, sorry, the Pythagorean theorem version of this, or the distance formula version, or which is really called standard form, but this is basically another way of looking at the Pythagorean theorem. Okay, so 4 here is, let's think of this one as a bonus question. This is not a super important thing to do, but you're hoping for an A in the class. Let's try a little challenge here. So for people who are not going to go into the bonus question, let me just remind you about the homework for this section. I'm going to post the due date on Canvas, and you're just going to do it on your own paper and email me a photo of your answers to every single one of these questions that are on the PDF. Okay, so what we're going to do is go from something that is in this general quadratic form and try to complete the square. To sort of go backwards from something like this into this, to this, to something that looks like this. So let's try to follow these steps here. We're going to collect the x terms, the x squared minus 14x plus y squared plus 4y equals negative 25. And then we're going to complete the square with x and y. So the negative 14 is going to be like the 2rx. So I'm going to write this out again here just to see it. We have x squared minus 2rx plus r squared. We want to turn it into x squared, x minus r squared here. But that negative 14, I'm going to work this out on the side, that negative 14 is the negative 2r part. So what is the r? If you divide both sides by 2, you get negative 7 is r. And that means r squared, if you square both sides of that, is going to be 49. So this part here needs to have an extra 49 added onto it. And I'm also going to add it onto the other side of the equation too to keep it balanced. So this is going to become x squared minus 14x plus 49. That part is now a perfect square, a perfect square trinomial that we can write as x minus 7 squared. But because I added this plus 49 here, I got to do the same thing to the other side. And then we're going to do the same thing here with the y in the next step too. So the 4 in this case is the 2r. So the formula we're using there is y squared plus 2ry plus r squared is the same as y plus r quantity squared. But the 4 is the 2r, so you just divide both sides by 2 and you get 2 equals r, and if you square both sides you'll get 4 is r squared here. So I'm going to make a little room, and I'm going to take the plus y squared plus 4y and add 4 to that. But we also got to add 4 to the other side over here. So I added 49 to the left and 4 to the left, so we got to add 49 and 4 to the right as well. So that's going to be, let's see, negative 25 plus 49 plus 4 is 28. Okay, so anyways, this stuff here turns into x minus 7 squared. The y squared plus 4y plus 4 turns into y plus 2 quantity squared. And then the other side, you just have 28. And 28, if we're trying to write it as in the form of like something squared, like the 16 is 4 squared, right? What is it that you can square to get 28? Well, how about the square root? So I'm just going to write that as the square root of 28 squared, which is the same thing as 28. But this way you can see that the thing that's being squared on the other side here is the square root of 28. So that's the radius, which is a little bit more than 5. Let's see. 5.29. And the center is, well, this is x minus 7 quantity squared, so that's 7 is the x coordinate, and y plus 2 is the same thing as y minus negative 2. So it's 7, negative 2 is the center.
That might be slow.
All right, for C, I need to stop making a video because my family wants the living room, but I'm just going to work it out here while it's paused and then show you the answer in a minute. But this is another one where you want to try to do the same, completing the square steps. This is also a challenge problem. Not really required, but you should try it if you think you can. And here is the answer for that. Very tricky problem. If you got this, you deserve heaps of praise. I wish we were all in class so I could give it to you, but that's a pretty tricky problem to do on your own. So good luck with this work. Feel free to come to office hours because you will probably need some help with some of it. And I hope to see you there, and have a good day.